So we are in Introduction to Statistical Learning. We're in Chapter 5, and we're just starting the applied questions. Question 5. Multi-parter, A through D, so we'll look at them one at a time. But here's the question. In Chapter 4, we use logistic regression to predict the probability of default using income and balance on the default data set. Okay, so just generally, or just roughly speaking, this is a data set looking at a borrower's propensity to default on their loan given their income, the balance of their loan, etc. Okay, and that data set was called default, capital D default. So we will now estimate the test error of this logistic regression model using a validation set approach. Okay. So we will go through parts A, B, C, D. Okay. So first we need to install the ISLR2 package, load it, and then get a hold of our data here. The data is called default. I'm just calling it lowercase d, and we can look at what that, see what that looks like here. Okay, so the data set itself is much larger, but we're looking at the first 6 rows, but you can see that we have default as a factor. It's yes or no, they defaulted or they didn't. They're a student or not, what is their current balance on the loan, and what is their income. Okay. So for part A, we're going to fit a regression model that tries to predict default using balance and income. Okay, so that's what I do here. Okay, so it's just a GLM function, just a basic function in R. I make my formula. So here I'm using income and balance, and I'm using an interaction term in here. You might not believe that there's an interaction term and just use the plus, or you could even test that, but we're not going to do that here. It's a binomial distribution, and so with binomial distribution, or in other words, logistic regression, we use the logit link function. Okay, so we can run this and see what we see. Okay, the question doesn't really ask us to go into the summary here, and that's fine, but we could look at this a little bit, and we would realize that that balance seems to be a significant predictor of default, and so it seems that the greater their balance, the more likely they are to default. Okay. Now in part B here, we're going to use the validation set approach to estimate the test error of the model. Okay, and so in order to do that, we have to follow these steps. And I've just broken these out into different code boxes, so we'll do it as we go along here. So the first thing we need to do is to just split the sample set into into a training set and a validation set. Okay, so I'm saying I want 2/3 of my data to be training, but you could set this to whatever you wanted. Maybe a half is what a lot of people will do. And then I want to say, well, how many observations is that? So it's 2/3 of the total cases in my data set. Okay. And now I'm going to randomly sample the rows of my data set. Okay, so I'm sampling maybe I need to do that actually. So I'm sampling 1 through the n rows of my data set. Okay. How many samples am I taking? Well, I'm taking train n, okay, which should be 2/3 of all of the rows without replacement. So in other words, after I pull a sample, I can't sample it again. Okay. And then my training set is just my data with just the rows that were created in the training index, and then the testing data is just the remaining data. Okay, so I can run that. Okay, so part 2, we want to fit a logistic regression on this. Okay, so that's what I'll do here. Just like we previously did, we could look at the summary if we wanted to. In fact, maybe we'll do that, and we could even compare them. Once again, we see that a very significant indicator of defaulting is balance, and it looks like the coefficient is pretty similar. And it should make sense that this is similar to the regression we ran on the full data set, because mostly the full data set. It's 2/3 of the full data set. So, okay. So the third thing we need to do is we need to use a predict function. So first we're going to predict using the model from the model that we just trained on a new data set. What is that new data? Well, it's d-test, right? And so this will spit out a bunch of probabilities of defaulting, okay, according to the logistic regression. And then what we need to do is we need to say, if we're greater than 50% of defaulting, we're going to say that yes, it's predicted that they default. Otherwise, no. Okay. So again, if the prob's 0 is less than 50%, then we're going to predict that they don't default. If it's above 50%, we're going to predict that yes, they do default. And you could set this to different values depending on, well, a lot of things, I guess. If you were a lender and you were very leery of people defaulting, you might set this to 40% or 30%, right? And so people that are 30% likely to default, you might not want to give them a loan, for instance, or you may want to impose more penalties, or it may change your business practices. But okay, so we run this, and then we're going to look at the error rate. So first we're going to look at, so we'll have a table here, okay, that will show our predictions versus what is actually contained in the test set, all right? And then we can look at the error rate, and we can do it in a couple of different ways. So the first one is just the straight prediction error rate, okay? So, well, in fact, let me just run these here, okay? So here's our table. So, so this is us predicting yes or no, and this is whether it was actually yes or no, okay? So when we predict no and it is in fact no, that happens this many times, okay? Conversely, when we predict yes and it was yes, it was this, and then we get it wrong 86 plus 10% of the time, or 86 plus 10 out of all of these, all of the instances in our test data set, okay? So one way that we could kind of estimate error rate is to say, well, how many predictions did we get wrong, okay? So it would be 96 divided by, you know, the total sum of all of this, okay? And so that is about 3% of predictions are incorrect. But another way that we could do this is the following. So remember that we had not only predictions, which were yes or no, but we had probabilities, right? Well, now these probabilities are rarely going to be 1 or 0, right? They're going to be somewhere in between 0% and 100%, okay? And so in some way, if somebody does default, if a model says that that they were, call it, you know, 51% likely to default, and they default, in a way we want to say that that is a worse prediction than if the model said that they were 90% likely to default, and in fact they defaulted, okay? And so so the distance to the correct prediction is an indicator of how correct or incorrect our predictions are. And so we can also do that here with this code. And so on average, the percent error rate is about 4.36 percentage points. Okay. Anyway, so we'll go now to part C. Okay. And so in part C, what we're supposed to do is to repeat everything that we have just done, but to do it 3 times. And I'm actually going to make it 10 times, just because you know, I can change it to whatever number I want, and we're going to be asked to compare this to something else later. So, so all I'm doing is I am saying how many times I want to repeat all of that, and then I'm copy and pasting basically everything we've just done into a function that I'm calling perform analysis. Okay? And then I make a for loop for, you know, however, for the number of replications I want to run the function perform analysis on the data set on the data set D. Okay, so again, what's going to happen is I'm going to take the data set D, I'm going to create unique training and testing sets each time, and then run through the analysis, okay? And again, the question asks for 3 times. I'm going to do it 10 just so we get a larger sample and it just, you know, same amount of time. And so, you know, so we get the prediction error rates across all of these, and then the percentage points error rates across each run. Okay, so you can look at those. But in part D, we are asked to do the same thing, but also to add student into the mix. Okay, so this is the same code that we just saw, except the training model now has student in there. And again, I've made this an interaction, so this is quite a complicated model. So we have 3 major terms, and then we have 3 one-way interactions, and then 1 three-way interaction. So, but anyway, we run this, okay? And again, we get 10 error rates. And there's more rigorous ways to do this. We could, than what we're doing right here, we could actually store these values and compare them to the previous runs. But it just asks us to to visually compare them. So we're looking at them, and to me, the values look very, very similar. And so it doesn't seem that adding student really makes any difference in the error rate. Okay, we'll call that good.